This is the demonstration of my computer, which is modular. It's a modular computer made completely by hand. This is just a normal perf board. Look in the back, it's just perf board, proto board. And we have two modules I've created right now. This is the CPU module. This is the MENCH computer, which is a small microcontroller that allows you to pretty much use it as a normal 6502 or a 65816. And it's 16-bit, 8-bit, multiple. It runs pretty fast, has built-in I/O, a lot of cool stuff. Terminal built-in. It's great for debugging. This is the card I'm using just to get everything off the ground, really. If you look right here, this is just the main board in general. It's got, these are the address lines, these are the data lines, this is the second crystal, this is the main crystal. Actually, those switched around, that's the main crystal. And right here, you can see these are just, sadly, what they did was they made it so instead of using the chip select lines, I don't know, pins, just put some pins right there. No, they decided to make the chip select lines into LEDs. So I had to manually solder over, if you look right there, that's the chip select line for I/O, and then bring it all the way down there and wire wrap it right there for this NAND gate, which selects if I/O is being used. This is a standard RC 2014 bus right here, and that's why I need this, so it can detect when I/O is being used or not. I/O has a specific address, address space, which is well, it's not a different address space. By that I mean it's a location in memory. It's D something something something. It's DXXX. And if we look right here, we have, this is a RAM card. This is the same 32K of RAM I've been using for who knows how long. Sadly, the first 2K, I think, are broken, or they're just not storing information correctly. And then right here we have an OR gate to select the memory. I'm thinking I might have to go for diodes for OR gates because right now I don't have many 74HC32s, or in this case 74LS32s. So what these go in is this board right here. I have metal, just normal, something covered with copper wire as the bus connectors, the bus wiring. I'll be honest here, I did that because I didn't think of doing actual under the board wires, but it does give the benefit of not being like wire where you can accidentally break it, but it does have the disadvantage of if you push too hard, it might dislodge the copper covering on the bottom from the pins. But these are all hand soldered, and I did do this one like that for some reason because that was my original plan, just have soldering, and I'm like, oh wow, that's going to be difficult. There's only 2 slots right now, and look right here, there's an LED with a resistor that indicates if it's on or off. This one doesn't have one because this thing entirely lights up like crazy, but this one has a lot of features, so I'll just plug it in. So what I do is I switch the camera to the other hand and plug it in right here. This is a little difficult to do. There we go. Crunch. See, did anything break? Good, nothing broke. Now I can plug it in. This is the only modular computer I know of which uses the MENCH computer as a base. Hopefully that's the right way. There we go. Gotta plug it in a little bit more. Here, that should work, and there's the main thing. This also has a built-in 128 bytes of RAM at the first, something, I don't know, 100. First 128 bytes of RAM are memory. So, let's see. Okay, good. We're still connected. Let's go to memory address 000000 and see what we can set there. Let's just set some stuff. This is the monitor built into the ROM. So let's set it to dead beef. And now I press enter, and then go to M00000, and there you see dead beef. So now let's go to something that's set inside the memory. So 3000. This should be blank. Now if I set to FFFF, FE, and then let's read 003,000. You'll see it didn't go through right. It's just cached with the last value, and that's not good. So let's plug in the RAM right here to the RAM card slot. Just a normal RC 2014 bus. There we go. It's plugged in like that. Pretty nice. This is just all wired. If you want to look at the back, I'll show it later. And also, I'm going to show this is the connector I use. It's just a breadboard with a UART to USB. And now I can finally do something like 44, 55, 66, 77, 88. Now if I go M003000, there we go. 44, 55, 66, 77, 88, and 89 apparently, because the memory isn't fully cleared out. If you want to see that bug I was talking about, let's go 0, let's see, where's the first one? 004, nope, that's not it. M0004, that's 300. And then if I press this long enough, you'll see that. 000, oops, 3. Oh, that's weird. Okay, yeah, it's because I'm using PuTTY versus another terminal, which let me backspace. You'll see, yeah, this does not look correct. Well, it does look correct. That's actually nice. I think it's actually at 0200 where the issue is at. Let's set to 1, 2, 3, 4, 5. There we go. Yep, there's the issue. At 200, there's an issue with the memory. That's where the broken part is. You see, it didn't store correctly. You see the number 256 got saved, but not a lot. So how it works is the cards, it connects a memory bus and a data bus together. Well, not together. I mean, they're on the same pin bus interface. They're not multiplexed or anything, but this has all the pins. This has data, power, address, and IO/memory selectors, which are generated because this bus was originally made for the Z80, which has a separate I/O space and I/O pins. And right here we have, of course, I already explained that part, but I'll show you the back of this card now. These cards. So you take them out, presumably with more than one hand, and we'll look at the back. So this is how I soldered them together. They're just soldered. I know it kind of looks kind of bad, but it's fine. It works. Well, except if you try to access the first whatever bytes. And these chips are in sockets. So if they break, I can replace them. If you look right here, this one, BlackBerry camera, it's not good. Okay, it's kind of hard to focus on it. Okay, once you can see, now the entire thing's out of focus. This one already has a broken off pin, which I had to resolder on. And right here, we'll look at the back of this one. This one has similar soldering on it, but this uses a NAND gate because no OR gate, so it's acting as an OR gate instead of a NAND gate. So this was originally just one big sheet of what's called a proto board, and I cut it out just with my bare hands, of course, and some pliers and like scissors. So you don't want to use actually a cutter on this. It doesn't work well. Because it's perforated, you just break it off. So what I'm going to do next, because I already have the RAM card and the ROM card, I'm going to make a RAM card and a CPU card. I'm going to make the ROM card last of all. But before I make ROM, I'm going to make the display card that lets you see things on the screen. On a screen, it's not sentence segment, it's an LCD, character LCD, which will be pretty easy to do. And then after that, I'm going to make probably an audio/IO card using a Yamaha chip or I forgot what the name of it, General Instruments card. So that's about it right here with my computer so far, and I think it's pretty cool, and hopefully you think the same.